This is obviously surfacing for solid modelers. How many of you have made a solid model before? All right, cool. Great. So you're going to do fine in this little presentation, following along. How many of you have tried surfacing before, some of the surfacing tools? Okay, cool. It's a common, conception that surfacing is kind of mystical. People think that it's only for making really organic shapes and weird types of geometry, but there's a lot of applications where solid modelers in their standard workflows can use surfacing tricks to really help out when we don't have the solid modeling tools to do what we exactly want it to. So what we're going to be learning today is everything that you see here on the surfacing tab that's highlighted or colored in. So it's actually a majority of the features that are on that tab that we're going to be covering in the short 60 minutes. That's why I wanted to get started right on time. So like I mentioned, most of the time people think surfacing is only for making organic shapes like you see on the right-hand side. Obviously on the left-hand side, we're making that model with a series of extrusions, fillet features, cuts, and regular solid modeling tools. But we can obtain a much more organic shape with surfacing, but that's not the only reason to use surfacing. So a little bit about myself, since you're going to be spending the next 60 minutes with me. My name's Jordan Taddick. Most important thing to know is that I'm very informal. So this is kind of a small room. You guys have filled it up pretty well, but feel free to, no need to raise your hand because I might not see it. I might not be paying attention, so just shout out at any time if you have a question. Hopefully we won't get derailed too much, but what's that? I'm from Cleveland. Go Browns, right? All right. So CAD experience, I've worked on multiple platforms, and currently I'm an elite application engineer at 3D Vision Technologies. The elite part is just kind of a recognition of how many certification tests I've taken. It's just saying that I'm a big-time nerd, so it's nothing to brag about. So why surface modeling? Well, because there's a couple of rules that really limit our solid modeling techniques. And the really big one is that every single face that we create when we're working with solid modeling tools must be, or every edge must be the meeting point between exactly two faces, no more, no less. So one of the issues that we sometimes see is a zero thickness issue. That's like if we extrude up both of those rectangles at once. SolidWorks will actually let you do this now, but it's not supposed to on the kernel. And then you see the wavy surface over there surrounded by those blue edges. That's obviously a surface. No way to make that geometry with a solid. So again, every edge needs to be bound by two surfaces inside of a completely watertight solid model. So if we did have any open edges, we'd have a leak and the water would spill out. So the reason that's kind of limiting is because the way surface modelers typically work is they don't know the entire geometry at once. They build a little piece over here, a little piece over there, and then they work on blending all that together and filling in the final shape. So, you can see how he started making the fender details in the wheel well, and then blending those surfaces together. I didn't make this model, but I did download it from grabcad.com, which is a great online resource to download models. There's a lot of native SolidWorks files on there, and there's no better way to learn than just downloading a model and browsing through the feature tree, seeing all the features that they used to create a model and the options that they had turned on. So yeah, moral of the story here is there's no extrude and Audi R8 button inside of SolidWorks. Unfortunately. Maybe 2014. We'll find out on Wednesday. So again, a lot of people are intimidated by surfaces. So don't be. Solid modeling tools that we have are actually nothing more than automated surfacing tools. When we're making a box, it's making all the faces, and then it's just doing one additional feature or calculation of filling that with the solid material. But you could almost break down every single solid modeling tool into a series of surfacing tools. Like in this case, a shell feature, you could think of it as it removes a face, the faces that you select, and it keeps the rest of them and just thickens them. So those happen to be a couple of surfacing tools on the surfacing tab of the command manager. So there's a basic workflow from going to surfaces to solids, because still the end product that we want is a solid eventually. It's just the path that we use to get there. So I want to show you this in SolidWorks really quick. We'll just go ahead and start up a new part file. And what I'm going to do is just show you some of the very simple tools on the surfacing tab. So I'm going to start a sketch on this top plane, draw a circle, and on the surfacing tab I'm just going to use the very first feature, the extrude surface. Okay? So I just want to make sure everybody's on the same page. I know a lot of people raise their hands when they mention they'd used the surfacing tools before. We're going to start off really basic and then get into some more exciting examples after that. So I'm just extruding that circle, and what we end up with is a zero thickness surface. Okay? No solid. There's no mass to this model just yet. And the other very important thing to notice is that every single open edge has a blue edge. So this edge down here and that edge down there might be hard to see on the screen with the contrast, but those are highlighted in blue. And that's a typical color from the default settings. So now I'm going to also, on that top plane, draw another sketch. And this time I'll draw a rectangle. All right, just surrounding the perimeter of that circular extrusion. This time what I'm going to do is, with this enclosed contour, is create a planar surface. All right, so what that's going to do is, obviously most sketches are 2D sketches. You could draw any enclosed contour and select it and hit OK, and what I have now is a second surface to my model. Okay? So what I'm going to end up doing is making a cylinder the hard way rather than just extruding that circle from the start. Just to show you some of these tools. So another way to make a planar surface, which is kind of nice for capping off a surface model, is to fire it up. Without even having a sketch, I could just select this circular edge, and as long as that edge is on a planar surface, it will fill that enclosed profile with a surface as well. So if we look up at the top of the feature tree, we have our solid bodies folder, which we have none so far, it's empty. And we have a surface body folder that has 3 surfaces listed in the order that they were created. Okay? So the question is, how do we now go from these 3 surfaces to an enclosed solid model? Well, the first thing that I like to do, and I like to think of it as, you know, we're working with fabric. My father was a tailor, so that just seems natural to me. But I'm going to, if I was wanting to make this with fabric, I would want to trim away the extra material and then go ahead and stitch up all the edges, right? So that's exactly what we're doing in the SolidWorks realm as well. I'm going to use this trim surface command. And the way that I'm going to use it, it has 2 modes. I'll probably show you the mutual mode as well. But the first way I'll show you is a standard mode. And that is using a trim tool. So I'm going to select this cylindrical surface as my trimming tool, as my cutting tool. And then what I have a choice to do is either choose the surfaces that may or may not be cut by that trim tool. And I could either pick the sections that I want to keep. So in that case, I could select that, or I could specify the sections that I want to remove, which may sometimes be easier if you have a bunch of split surfaces from that trim tool. Still, though, we still have 3 different surface bodies. So the trick here now is to knit them together, to stitch up each one of those edges. So to convert these blue edges into black edges, model edges. All right? So I'm going to go ahead and fire up the knit surface command, and I'm going to select all of the surfaces that I want SolidWorks to stitch together. As long as they are meeting together at the same edge, so they're trimmed appropriately, we're going to have no problem using this tool. So I'm just going to hit OK right now. And you'll see that those edges have turned from blue to black. So this has converted from 3 bodies into 1. We stitched them all together. But that's still a surface body. So the question is how do we convert this to a solid body? Well, there's 2 ways to do so. One way is with the knit surface tool. So if I go back into that feature that I just created and edit it, one of the other options that I have here as a final step is to check on try to form solid. So if you're knitting a bunch of surfaces together and they all end up filling an enclosed contour or volume, then it's going to also fill that with the solid model. So just by editing that checkbox, I now, rather than have any surface bodies left, I now have one single solid body. Okay? I also have one other option, so I'm going to edit this and uncheck that, so I'm left with one stitched surface body. This is helpful to know if you ever import a surface body. It comes in as a surface body rather than a solid body. A quick way to convert a completely watertight surface body into a solid body is to use the thicken command. And we'll talk more about this tool a little bit later. But what I'm going to do right now is just select this surface body and tell it to, rather than specifying a thickness, I'm going to just create a solid from the enclosed volume. And in that case, it just fills the inside. Okay? So those are 2 ways to go from surfaces to solids. And what I also want to cover is how to go from a solid to a surface. Okay? So there might be multiple reasons that you'd want to do this. And the easiest way to do it is what's shown up there. So I'm going to demonstrate this really quick. So say we wanted to turn this back into surface body. Well, the easiest way would be to delete the thicken feature, but if this was imported, right, we wouldn't have those features to modify. So another option is to copy this surface up on the top, then delete it, and then stitch the bodies back together. But first what I'm going to do is I'm going to delete this a little bit out of order. So there's an option called delete face. We're going to look at this in much more detail because it's an extremely useful tool. But right now I'm just going to use it in its most basic mode, and that's just to delete that face. If I were to delete that face, that solid body becomes no longer completely enclosed or watertight. So what happens? That edge turns blue. And now we're left with a surface body instead of a solid body, right? So it's pretty obvious that we need to, that's the simplest way to convert that over into a surface body. What if we wanted it to be a completely enclosed surface body? Well, what I could do before deleting that face, I'm going to roll this rollback bar up. I can first copy that top surface. And what I'm using to copy, let me step back, is the offset surface command. This is kind of weird how it works. If I select this face, it shows me a little preview offsetting that surface. That's how we'd expect it to work. But take a look at the name up here at the top of the feature, or the property manager. If I change this offset to 0, you're going to see that the name actually changes to copy surface. So that's how we activate the copy surface command, actually. If I copy that surface, I got a surface up at the top. I got a solid body still. But as soon as I reapply that delete face, now we have just 2 surface bodies. And again, I can knit those together and thicken them to form a solid. Okay? So that's a quick overview of how solids and surface bodies are related and how we can convert from one to the other. So now we'll look at some more interesting applications, all right, that I think you guys will find pretty useful. These are all the example files that we're going to cover in the next 45 minutes or so. And I'm going to start with one of the simplest ones to use, all right, and that is the delete face. Now, delete face is useful for all kinds of scenarios. One could be cleaning up solid models very quickly, and I'll show you a few examples of that. The other is, well, how many people use or have to use in their workflows imported geometry? Okay, so I got a lot of goodies for you guys as well. One of the things about import geometry is like we have customers using purchase components, importing it to their assemblies, and to minimize the load on their computers, the models that they're bringing in can be way over detailed. Okay, so as far as simplifying the geometry, you can really accomplish simplified configuration of imported geometry. Obviously, we can't have the entire feature tree on imported geometry to start suppressing features, fillets, and all that. So the delete face command becomes very useful for simplifying imported geometry as well. So let's take a look at a couple examples here. First one, say we are working on a model that we're modeling natively inside of SolidWorks. We created a solid body that looks like this. We went ahead and shelled it out, and then we created a revolve feature, okay, that maybe a little mounting boss or who knows. If I look at the sketch of this where it's located, let's flip that around. It's created on that inside curve, but unfortunately what happens is it extends past the outer face, okay? So normally what we would probably do using solid modeling tools is go ahead and find that same exact sketch or convert the entity of that outside edge, revolve cut around that swooping surface on the outside. But another option that is much more easier to use is the delete face command, which is right up here. And you can see how simple, pay attention to how simple these surfacing property managers are. There's not many options. You're going to notice that they're extremely easy to use. This mode right here is very powerful, the delete and patch mode. What this allows me to do is pick the faces that I want to get rid of. Now if I just selected delete, what would that do? It would actually convert it to a surface model, and we'd have a little hole there, right? Because it would no longer be watertight. But what this command also does, just with a single check mark, is it goes ahead and patches as well once it deletes those faces, maintaining the integrity of your solid body, so it keeps that solid. So surface, or the delete face command is on the surfacing tab, but it's certainly a solid modeling technique as well. I'll show you another example that maybe you guys have run into or not. And that is, actually these two faces were supposed to be transparent. Let me edit that really quick, so we could see what's going on a little bit better inside here. Alright, so what we have here is a block and a hole cut into it with the hole wizard feature. Now, this hole wizard feature was located on a 2D plane that happened to intersect this face at an angle. So the point that we inserted this was on this outer face right here, and we inserted that in at like a 45-degree angle. Well, the bad part that happens is it only cuts in one direction, so we're left with this little overlap. We're going to have a hard time threading in a fastener to that hole with that overlap, and that's going to be pretty hard to machine too, I'd suppose. So a really quick fix for this, some people might start a sketch on this face, convert all the entities, extrude cut in the opposite direction. But even more lightweight than that and a bit easier to do is to just fire up the delete face command, select that face, make sure delete and patch is on, and that fixes it perfectly. So what it does is it removes that face and extends the surrounding faces until they intersect one another, and that's it. Pretty simple. All right. One more example is this imported geometry. And obviously with imported geometry it's always a challenge because, like I mentioned, the features aren't there for us to modify the parameters, suppress or unsuppress features. This is nothing more than a surfacing obstacle course that I created. I have no idea what this part is. It's actually multiple parts brought into one and all merged together. So I just didn't want to keep on closing and opening files. So what we can do here is I just want to demonstrate that the power of the delete face command a little bit more. And that is, if this was imported geometry and we didn't need this block here, or let's start off with something more simple, like we didn't need those holes. All right? This face right here on the outer portion of this kind of dome area, that's a lofted surface, so a pretty complex surface. It's lofting between 4 different profiles. And again, we'd probably suppose that that's going to be tough for SolidWorks to patch, but it's actually not at all. So first thing I'm going to do is we can see that these holes go through over to that curved surface on the inside and up to this surface at the top of this little boss feature. I'm going to go ahead and select this face, and luckily we have these little selection tools that can help us pick multiple faces at once, speed up the process a little bit. So what I've done is I've selected all the inside faces of that hole. I'm going to select delete and patch, and it fills in that surface, fills in the surface on that top as well. Pretty simple. What if I wanted to get rid of all of that entire feature? I could run that command one more time, or just edit the previous one. But let me go ahead and select all of these faces. Let's see which, oh, that option's a better one. There we go. So selecting all those, delete and patch, and that whole chunk of material is gone as well. So you can see how you could use this very easily to simplify your geometry. Okay? Another almost equally simple to use surfacing command and very powerful is the replace face command. So all you need to do is you're going to need to create a surface to reference when you're using this tool. That's the only trick to it. Okay? So let me show you a couple of uses for it over here. And one could be, if we take a look at, say, the front plane on this model, I'm going to start a sketch. Let's look at it from this side. And we have this star cutout with drafted faces on it. I'm just going to go ahead and draw a circle here. What would we do with solid modeling tools if we wanted to replace this star cutout with a circular cutout or cylindrical cutout, like a hole? If we take a look at the profile, we actually have areas where we'd have to add material and areas where we'd have to remove material as well, all at the same time. What I'm going to do is I'm going to create what's called a sacrificial surface. I'm just going to extrude that circle out. And I don't care actually how long it is. I'm just going to extrude it out a little bit. It doesn't matter. So we have a little surface, cylindrical surface floating right there. And what I want to do is I want to replace these inside faces. So if I fire up the replace face command, again, a very simple property manager. All I'm going to do is right click and hit select tangency to select all those inside faces. And then I'm going to pick the face that I want to replace those orange highlighted faces with. So it's going to be this one. And even though they're not intersecting, that feature works very easily. So it's adding material, it's removing material all at the same time. Now the reason I called this surface a sacrificial surface is because at this point I don't need it anymore. So I'm going to sacrifice it. It helped me out, and now I'm betraying it, and I'm just going to delete it. So if we have no more use for that surface, just select it from the surface bodies folder and hit the delete key and hit OK. That fires up the delete body command. And from this point on in the feature tree, that surface no longer exists. All right, before it, man, that blue bar is so hard to click on sometimes. Before it's there, and after it's not. All right. Now, another way to use this tool, I'm just going to delete that hole altogether. And I've already created another little surface here that I'm going to go ahead and show. Now, this is a revolved surface. So just like an extrusion, we could draw a profile and either extrude or revolve it, and it would have 0 thickness. But you can see that it's kind of intersecting the model, and there's gaps between that surface and the model as well. Again, this is that lofted geometry, so you can see there's a little gap right there between it and the surface model. So if we needed to have that dome shape follow that orange contoured surface, how would we even accomplish that with solid modeling tools? It would be very, very hard, all right? So what we could do is, or it would take quite a few steps. What we could do instead is use the replace face command and replace this face with that surface. Hit OK, and it goes ahead and extends and cuts the material at the same time. Once again, I could, now normally I would just go ahead and drag, well, let's do that. I'll drag that delete body command all the way down to the bottom of the feature tree, edit it, and I'll also delete this surface as well. All right, so now we have no more surface bodies in our feature tree, and our model's pretty clean. Another very, very simple to use surface tool is the cut with surface. Maybe you guys have already used this. A lot of people have. If I select the right plane and select cut with surface, this is the easiest property manager in all of SolidWorks. We only have one option, to change that little gray arrow's direction. And if you click on the gray arrow, it will do it right from the graphics area. I'm going to point it in the right direction because that's the direction of the material that I want to remove. So we could use that with a plane, or we could use that with surfaces as well. Planes extend infinitely in all directions. Surfaces are confined to the size of their surface. So that's why that could be, the cut with surface can sometimes be more beneficial than, just drawing an extrude cut or a line and extrude cutting and cutting everything to the right or left of it. It's more confined. Now here's another scenario where the replace face command comes in handy. And maybe you guys have run into this, maybe you haven't, but this is probably one of the most frustrating situations. And it's because SolidWorks is the most precise, well, very precise CAD system. I don't know if it's the most or not, so I can't say that. But it's very precise. A lot more than some of the other major CAD packages in the industry that we find. So what I'm going to do is I'm going to create a feature called the wrap feature. All right. Now, I just started a sketch on this plane, and what I'm going to do is just go ahead and write out my name. So I'm going to create a construction line. I always like to do that when I'm creating sketch text. And I'll write up here Jordan. Let's make that bigger. Okay? Now, if I were to just extrude this guy into this face, like if I wanted to cut it, this is a cylindrical surface. What I actually want to do is wrap it across that cylindrical surface. There's a feature for that. That's a regular solid body feature command. But the way it works is it allows me to pick a sketch, like this guy right here, and then pick a face that I want to wrap it onto. But what we're going to see is that, if I move my mouse just a little bit, the wrap takes a planar, cylindrical, conical, extruded, or a revolved face to be able to wrap that 2D image onto it, kind of like a decal. All right? So what's the problem? That's a cylindrical face, right? Well, the problem is that it's actually not. It's ever so slightly deformed in its profile that SolidWorks doesn't consider that to be a cylindrical face. SolidWorks measures everything down to the 1/8 decimal place depending on which units you're using. So if the previous CAD package wasn't as accurate as SolidWorks, it may or may not have converted it into an actual cylindrical edge, what it considers to be cylindrical. So here's the fix. I need this outside face to be cylindrical. What I'm going to do is make a cylindrical surface. So I'm going to start a sketch on this end face, draw a circle, and then align this with one of these segments. And by the way, the check to see if something's cylindrical or not is to click on a circular edge, what appears to be circular. If it's circular, down in the lower right-hand corner, the status bar, what we see is an arc length. That's telling me right away that that's not a cylindrical edge, okay? Otherwise, it would have given me the radius or the diameter and the center coordinates as well inside of the status bar down here. So what I'm going to do is I'm just going to align these two arcs together so that they're the same size. And then with that sketch that I just created, I'm going to create an extrude surface. Again, it doesn't matter what direction it's going. I'm going to have it go to the right just so it's easier to click. And now what I'm going to do is I'm going to replace this, what I thought was a cylindrical face, with the actual cylindrical surface that I just created. If I hit OK, it looks like nothing changed, but I'm just going to go ahead and delete that surface now. The true test is if we retry that wrap feature. I'm going to select that sketch and then select that face, and sure enough, it works fine. Okay? So it's a great way to repair geometry as well if it didn't come in as clean and as accurate as it should have. Okay? Any questions so far? Yep.
Yeah, the example of converting the star opening to a round and then deleting the surface that created it. If you had to put a dimension on that circle, where would you put it? Like, say you have to come back and change the size of that.
Oh yeah, absolutely. So the guy asked, how would we dimension or constrain the size of the circle that was used for the replace face on the star cutout? And that is, the surface that I created was the extrude surface, which is a sketch-based feature just like the extrude feature is. So just going into that sketch and adding a dimension to that circle, that initial circle that I drew, would constrain the size of it. And then I deleted it, yeah. So everything in the feature tree is time dependent. And at any time you can edit any one of the features in the entire feature tree. And when you edit a feature up towards the top of your tree, it actually is like going back in time and going to the state that you were when you initially created it. Are there any other immediate questions? Yeah?
The replace face, the surface doesn't have to intersect, but the cut with surface does have to intersect. Is that true?
The what surface?
When you did a cut with surface, you have to use it.
Yes, yes.
If it were a surface, it would have to fully intersect where you want it.
Exactly, yeah. The replace face is a little bit different like that. It can see the existing surface, and so it knows the extents to which it needs to extend the other surface that you're replacing it with. But yeah, that's right too. The cut with surface always needs to intersect. That's why it's actually kind of useful to use it sometimes.
When you did that wrap feature, did that just bring the sketch out to the cylinder with no thickness to the sketch?
Well, there's actually 3 options to that wrap feature. I could either emboss, so extrude radially from that surface, normal to it. Deboss, so cut away material, normal to that curved surface. Or what I did was scribe the surface, so it just split that into multiple faces. Maybe if I wanted that to be a label, I could then assign a different color to each one of those faces for the letters of my name or something like that. So it gives you 3 options there. What's that? Oh, absolutely. Everything, all these features, just like regular features, are configurable and can be controlled by a design table as well. Yep. All right, so just to move on, the knit surface command, I kind of already showed it to you, but it's useful in a situation like this. When we're solid modeling, if we want to use the offset from surface end condition, sometimes it's a little frustrating, and I'll show you why. And there's a workaround for it when we do run into this scenario. So let me fire this up, and we are going to work with this model. So I have a sketch here at the bottom. This was all created with solid body models. And I'm going to use this circular sketch down at the bottom of this to extrude upwards, okay? Now that's a typical end condition blind, but another end condition that we have is offset from surface. And what we could do is we could pick a surface to offset from if we're offsetting in the right direction, say 10 millimeters. Problem is that the name of that feature or end condition is offset from surface, singular, not plural. So as soon as I try to select another surface, it gets confused. It doesn't even know what it's doing. We could also tell by the selection box. It's a single, line of text high, so we can only select one thing. So here's a workaround. If I wanted to offset from all of these surfaces, what I'm going to do is I'm going to right-click and select tangency to select all of them. And then on the surfacing tab, I could either offset at a 0 distance to copy it, or another way to copy multiple surfaces that already exist is just to knit them together. What that does is it creates another surface body of those faces, okay? Skinned right over the top of the existing faces. The cool thing is that now I could go ahead and extrude this feature, that circle, all offset from surface, and now I'll just pick that entire surface body, and I'll reverse the offset. Okay, and that's a way that we're referencing the surfaces that were created by the original solid geometry tools, but we created just another sacrificial surface so that we could reference all those faces at once. We're kind of tricking SolidWorks. The nice thing about this, though, is that that knit feature is always based on the solid model's faces. So if they change, the surface will change, the offset from surface end condition will change as well. So that it's always still a very tight relationship to the original geometry. Okay?
Can you use that same thing for cut up to surface?
Yeah, sure. Absolutely. Yeah, so the question was, could we use it for the cut end condition offset from surface as well, and that's absolutely true. This is another hole wizard dilemma that we sometimes run into, and that is if we're creating a hole in a, like a countersunk hole in a strange location, sometimes the surfaces of that countersink can be covered up. So the solid model that I have as an example right here is that we created this hole on this face right here, and it's creating that hole normal to the surface, but it doesn't know that that surface eventually curves up above the initial plane that it was created on and covers that hole. It's not going to extrude cut in the opposite direction, the hole wizard. Unfortunately, we can't use delete face right here because it's a little bit too complicated with all these surfaces converging into a similar area. Sometimes that happens. Here's a workaround though. What I'm going to do is go to the surfacing tab, offset that surface, or I could have knit it. It doesn't matter. Either one of these is the same. A 0 offset is a copy surface. And what I'm going to do is quickly hide that solid body. So I'll just toggle it off. So we're just left with the surface geometry. And what I'm going to do here is use extend surface right up here. Another pretty simple property manager, I'm just going to select on these edges, all right, and wrap those around that edge, and all it does is extend the surface. So I also think that the names of these surfacing tools all make a whole lot of sense as well. I'm going to go ahead and show my solid body again. So we have a solid body and a surface body, and you might guess that we're just going to cut with the surface I made. So I'm going to select this and make sure that arrow is pointing towards the inside, the direction that we want to remove the geometry from. And there's the cut, based on that original face that was created from that countersink feature. Again, I could, if I want to clean up my model, select this guy and hit delete, and that body is gone. And to further answer your question, again, before that delete body feature was created, that surface existed. So it's when we're using the surface cut that body existed, and it's when we're done creating that surface cut that we no longer need it. So it's all time dependent. Okay?
Would that preserve the whole wizard callout? Drawing to that part?
Yep. Yeah. Good question. The question was, would that preserve the whole call out on that feature? And yes, it would.
You can actually modify the holes.
What's that?
You can actually modify the holes.
I didn't necessarily modify a hole. I copied that surface and made a cut near the hole. Yep, exactly. How many people work with sheet metal in here? Awesome. You guys are a perfect crowd for this presentation. So sheet metal, talking about how confining surface modeling or solid body modeling is, everything having to be watertight and all that. Sheet metal has a few very constricting rules of its own, and that is that the entire model has to be uniform thickness. Okay, there's very few exceptions to all these rules, I know, but for the most part, all bends must be cylindrical or conical if you want to be able to flatten it. No wavy faces, so all the faces that seem flat must be flat, and all faces must be tangent if those things are all true. So there's a few ways to check imported geometry. If we want to import geometry, it should be a very simple process now, ever since the convert to sheet metal tool existed, to flatten that imported geometry. But sometimes things aren't as crisp and clean as they seem when they come in. Even if they come in with no errors, there might be a wavy face or something like that. So these are just a bullet point list of things that you could do as soon as you import the geometry and make sure that it fulfills all those rules. My favorite, the very first thing I do is actually at the bottom of the list. I right-click a face and hit Select Tangency. If I don't highlight all the faces on one side of the model, then I know there's something wrong. One of the bend faces is not tangent to the flat face, and right there we've already got ourselves a problem. Okay, so there are great ways to fix this geometry with surfacing tools. So that's the finished product that we want to get to, be able to flatten that guy out. And here's the process, and I'll walk you through this on SolidWorks as well. But what we're first going to do is copy the good surfaces, all right? We're going to get rid of the solid body then. So the only thing that we're keeping are the good surfaces, what's good about the import. I could then extend those surfaces to intersect one another and then fillet them. So now what I've got is one side of the sheet metal tool, or the sheet metal body, and all I have to do to convert that to a solid model is thicken it. And that's always going to be a uniform thickness, which is what sheet metal wants us to have anyways. There's a thicken tool. And then we just convert to sheet metal and flatten that. So let's go ahead and take a look at this. I'm going to bring in this imported geometry. And do exactly that. So some of those tricks, you know, if you click on a circular edge and it gives you an arc length rather than a radius, then you know that's not cylindrical and that's not going to be able to be flattened by SolidWorks. Another good trick is if you want to make sure that face is actually planar, click on it. If you don't see that sketch icon, you're not going to be able to create a 2D sketch on it. That means it's not a 2D plane. All right? So I'm going to go ahead and copy these good surfaces by offsetting them at a 0 distance. I'm going to delete that solid body because I no longer need it. There's too many things wrong with it. Another option is this untrimmed surface. It's very similar to the extend surface. The difference though is, there's a few differences, but for now the main reason I'm using it is because it allows me to extend multiple surface bodies at once. Okay? Rather than just one as the extend does. The unfortunate thing about the untrim is like it's based on a percentage. So you can see each one of the lengths of these is different. With the extend tool, we could actually say how far in a unit length that we want to extend that surface by. But we're not really worried. We just want to extend this a little bit. And even notice that there's some gaps between these surfaces. A very, very powerful filleting tool is on the manual mode, the face fillet. And actually when all else fails, if you're ever in a situation where you just can't fillet something, the face fillet works great. And the reason it does is because all the other modes we're selecting an edge. And that's nothing more than just a way to, a more automatic way of selecting two faces. Because in a solid model, an edge should always be bound by two faces. The longer way of selecting the faces is to select them individually. But the benefit is we have more flexibility on how SolidWorks is going to calculate this. So I'm going to bump this radius up to 2.5, and as long as it's big enough to bridge between that gap, we can go ahead and fillet that. So pretty powerful tool. And you just need to make sure that those two arrows are pointing in the right direction as well. And even if the surfaces are intersecting and overlapping, it will go ahead and act as a trim tool as well. Okay? So now I've got this. The final thing that I need to do here is thicken it. I'm just going to select that body and specify a thickness. So a thickness measurement probably would have been a good idea before I did this. But we could always roll back up and do it. And we also want to make sure that we're thickening to the right direction. So right now I have a perfect solid model to be able to be converted to sheet metal and then flattened. All right, question?
Could you accomplish the same thing by having deleted all of the
re-extruding cylindrical faces, or?
Not necessarily re-extruding them, but if you had deleted those faces and then added internal radii and then adding external radii?
Problem is that it's all about simplifying the workflow, and if we only deleted the cylindrical portions and kept the rest of the faces, we would have more surfaces to build. I'd have to not only build the inside radius, I'd also have to build the outside radius. Then I'd have to build the two surfaces that enclose the sides of those radial faces as well, or those cylindrical faces as well.
Can I now change the radius?
What's that?
Can I now change the radius so that I have a specified radius there?
Yeah, exactly. I could edit any one of these individual fillet features if I wanted to change that radius. Okay.
Would that work without the untrim? Like, did you have to untrim that, or could you fillet it straight from the faces?
The problem was with that, I could have, as long as my fillet was larger than the gap that was left behind. So part of the problem is that the curved surface created a wave that extended past the 1/4-inch fillet that was supposed to be there. So I just had to actually extend each one by just like a millimeter, and we would have been fine. Okay. All right, we got 15 minutes left. We're actually doing pretty well. This is a really cool one, and if you guys are interested in multi-body design, I'm doing a multi-body presentation tomorrow, and a lot of it is focused on this little part, making the buttons around this. It's actually a Wii controller. I actually downloaded the solid model off of GrabCAD once again. It was Jason T that modeled it, so props to him for doing so. But I'm just using it because what we want to do is we want to create that orange geometry, the grip. And obviously there's no way to do this with a solid modeling feature. And it might seem like a daunting task, but it's actually a pretty simple workflow. So I'm going to work through it right here. The first thing that we're going to want to do is I'm going to create a sketch on this side plane, the right plane. And I'm going to use the spline tool. Spline is nothing more than a curvy line. Probably all know that. I'm just going to create a 3-point spline and play around with these end control handles to kind of reshape it so it's curving around my model in the direction that I want the profile of the grip portion to go. So I'm just drawing the side profile of the grippy part that I can add to this little Wii controller. Okay? So what I'm going to do with this sketch is use a curve tool, which is called split line, to go ahead and split the faces of this model, similar to the wrap feature as it in scribe mode. It's not necessarily creating a surface or anything, but I'm just going to say extend that out and project it onto those curved surfaces. And what it does is it just splits those into multiple faces. We still have a solid model here. Those faces are exactly the same location. We could just, if I wanted to, color these differently. That would be a hokey way to do it, but I want to actually create the geometry. So now that I have these faces to select on, what I could do is come over to the surfacing tab and copy those once again. So I'm going to select all these and offset them by a 0 distance. So it copies them instead. And then from that surface, what I'm going to do is a very powerful feature, and that is if we created that grip, what we actually need to do is we need to cut away material so it's kind of recessed into it and can be assembled together, right? But how would we cut that? With an extrude cut, we'd always be cutting in just one linear direction. What we need to do is kind of radially cut all the way around it, normal to that surface, following the curvature of that surface. And this is a great way to do it. All I did was create another sacrificial surface around that original geometry, and I'm going to do a thicken cut. So I'm going to thicken that surface and remove the intersecting geometry from the original solid body. I just need to specify a distance. I think it's 0.05. We'll see if I'm right or not. And I need to specify a direction. So it's going inwards towards the model. I'm going to hit OK. And there we go. All right, so that's pretty nice. And then if we wanted to take it one step further, we could go ahead and create the actual rubber insert that's going in there. So I could select these faces once again, copy them, and then select that surface. And rather than thick and cut, I can just thicken it outwards, normal to the surface, by whatever thickness I want, say 0.1. And we just want to make sure that that's going in the right direction. You'll notice that we can go in one direction, the other direction, or use that existing surface as a midplane if I want to go equal distance in opposite directions. All right. I'm also going to uncheck merge result, which is kind of the process that I'm covering tomorrow. And what we'll end up with is two separate solid bodies, actually a few more because we got the buttons here. But now I have this guy. I could right click and isolate it, export that out to a part file, and there's my rubber grip. Okay? Add fillets to it, any other features.
Question?
Yep.
When you did the cut,
Mm-hmm.
did you put draft on that cut?
No, it's actually cutting normal to the surface. So I could, you know, as a separate feature, maybe add like a chamfer feature to the edge of that. Unfortunately, that would be really cool if we could add draft to that thick and cut. I could see how that could be useful, but right now it's just cutting in one direction that is perpendicular to the existing surface. Okay? Question?
Besides surfaces, say take that yellow grip that you have there, and I need to extend those surfaces. Sometimes they don't extend, they'll wrap back on themselves. Is there a reason for that, and how do you correct it?
Yeah. So when we're using the extend surface command, it's calculating the curvature at the end of that surface and trying to extend in that same curvature. So if there's like any slight ripple in there at all, sometimes what it could do is, like you explained, curve right on top of itself. The workaround for that is to create our own surface, a separate surface body, and then knit those together. And we could do that with a bunch of different ways. We could sweep a surface along an edge and draw the profile of it and make that profile tangent to the previous body, or with a spline if there is curvature and have continuous curvature between those two, but we could talk more about it afterwards as well. So here's that process once again. If you come back to this and download it, that's just it explained. Now this is a brand new tool. We've got 7 minutes left, so I just want to, this is probably the last one I'm going to demonstrate, and then I'm just going to cover the rest by explaining them. But the intersect tool was introduced in 2013, so this year, and this is an extremely simple tool to use. It's actually a bunch of surfacing commands and solid body commands wrapped up into one. But what we have here is a completely empty model of a bottle. So what if we wanted to find the internal volume? Well, there's like the combine feature, and that could take, you know, a handful of steps to be able to be left with the internal volume alone. The intersect feature is way too easy to use, so I had to show this to you guys. And it can be used with surfaces as well. But right now I'm just using a plane. I'm going to select the top plane, and a good keyboard shortcut is to control drag it to create a copy of it, offset. You could place this at whatever the liquid level height is going to be. So if I wanted to, I could name that plane liquid level height. And I'm going to intersect that plane with this solid body. And what this intersect feature does is it analyzes the geometry, and it will actually find voids that exist between multiple surfaces, multiple solid bodies, multiple planes, and fill those voids with a potential solid body that it can create. So right here we have three regions, three solid regions. And that is the top portion of the bottle, or I'm sorry, the bottom portion, the the internal geometry between the plane and the inside surfaces of that bottle, and then the top portion of the bottle. So what I want to do is I want to get rid of the bottle. So I'm going to check on those two bodies and hit OK. And now all we're left with is that internal volume, solid geometry. I could hit mass properties. I could assign this body water as its material and find out the mass and all of that. All right, so it's an extremely easy tool to use. There's a lot more scenarios to use it than that, and I show a couple of those to Mauro.
Can that be used in an assembly?
Yes, actually, with the join feature, you can use that kind of. All right, so I just want to walk through these last two examples in the next 5 minutes. And this is an interesting one that a customer came to me to ask how to create. All he had was a photo of this container. So I didn't have much information. I had the front view and the right view and kind of an isometric view. So what I always like to do is break things down into their most simple form. And since that's symmetrical, I'm only going to create a quarter of it and then mirror it a couple of times to create the rest. But I extruded that guy with draft. Then what I did is, from the images, I just plopped them into the file, the part file, and traced over the curvature that I saw for each one of those ribs. It kind of steps out each rib. Then what I did is probably the coolest tool, and that is a hold line face fillet. So with the face fillet, you can create a fillet that wraps all the way around the bottom edge without even specifying the radius. All you're doing is you're selecting the bottom curved edge as it wraps around that corner, and it's saying, hey, whatever radius I need to be tangent to the angled face and the bottom face, I'm going to pick that radius and vary throughout the entire length of that radius. So that's, again, a face fillet, and that's only available for a face fillet with the hold line feature. Copied each one of those surfaces. So now I have 3 surface bodies on the outside, skinning across the outside of this model. So what do I do now? I thicken the first one. I thicken the second one a little bit thicker. And I thicken the third one even thicker. So that creates my stepped geometry as we get towards the top. And then the rest is just solid modeling tools. I go ahead and thicken or delete the face, or shell it out, I'm sorry, and then mirror it across and maybe revolve the lip that goes around the top edge. This is another good example, and actually I presented this presentation at SolidWorks World 2011. I was eating lunch right before I presented it, kind of like I did today. And I noticed the centerpiece was the model that our customer, Libby Glass, sent me a few months before that I was going to use for the class. So I had to take a picture of it last minute and put it into the model. So it's kind of neat. So here's the idea. We revolve a surface. Just draw out the profile and revolve it. And the question was, how do we create that ruffle at the top? Well, I was racking my brain. As an engineering background, I always like to overcomplicate stuff. So I was thinking about, I was getting out my old calculus books and trying to figure out how to make like an angled sine curve that wrapped, or conical sine curve that wrapped around in a circle, and I couldn't figure it out. So the revolved surface up there at the top, the orange surface, is kind of like a plane, but we can't make a angled or a conical shaped plane like that. Again, it's a sacrificial surface that I want to reference. What I could draw was a ruffle shape, the wavy shape down at the bottom on a 2D plane. That's really simple. I just draw one and then do a sketch pattern all the way around. But then what I could do is I could project that wave up onto that conical surface with the project curve. It's another curve tool. And then that went ahead and generated the geometry that I was looking for, or that edge. So I deleted the sacrificial surface. And then all I had to do was one command, extremely easy, the loft command, loft surface, and lofted between the top circular edge and that projected curve. And that's what I was left with. Then the only thing that was left to do after that was thicken it, which we've already learned about as well. Okay? So what seems really complicated might not be so if we kind of reference surfaces. So using surfaces as reference geometry, like as we would planes, is an absolute very, very useful method as well. All right, so this is my information. If you have any questions, feel free to come up and ask. If I wasn't able to answer any, or I missed you or whatnot, and feel free to contact me at any time as well. All right, have a great SolidWorks world. Thank you.